Hello everyone. In this video we cover the Turing machine for the substring ABA. So this is the question: construct the Turing machine for the language of a string containing ABA substring. So which is formed by using this A and B because sigma is A and B. So let's start. So we construct this string with the help of the DFA. So first we draw the DFA, and by using this DFA we just translate this DFA into the Turing machine. Now how? Let's see here. So first at the initial state, Q1 state at the initial. So before that we see which is the regular language or the regular expression for this. So let's suppose the regular language is like A plus expression, we say that A plus B star ABA and A plus B star. So here only we want a substring ABA. Which substring is in the starting of the string? It can be in the middle of the string or it can be at the end of the string, no matter, only we want ABA substring. So this A plus B star means this bracket can be null also. N number of A, then n number of B's first come in front of this ABA substring. So in this way. So let's suppose we write here language also. So this can be ABA simply, means both string are the null and only this substring is present, or AA BB and then AB A substring is present, or AB then ABA and BBB, like this. N number of substring can be formed here. So now we start to construct the DFA first. So we know how we draw the DFA. So initially at the Q1 state, this is the initial state. So first we draw the constant substring which we required. So we want A, then Q2 state, then we want B, then Q3 state, and after that again A. So what we do, only we first write here ABA, which we want exactly ABA and which is compulsory for this string, and Q4. Now here for the DFA we know each state, from the each state both the symbols is transfer, means from this Q1 if A is go, then B is also present here. So where we transfer this B? So we transfer this B itself here, B, because the string can be start with A or the string can be start with B also, because n number of string is present before the substring. It can be possible. So let's suppose at the starting if this string is start with B, then it travel itself to the Q1, and again we consider this string, again B is come, then again it is transfer here in the Q1 state, then we read A, so we transfer here A, then we read B, we transfer here B, and then A. So this, in this way we do the actions. Now for this Q2 state, here from this B is transfer, but A is not transfer anywhere. So where we transfer? We transfer here itself, A, because this string is also now maintain here this sense, means if we transfer here n number of A, then also at the end here A is present. So ABA, this substring is formed here, so it is correct if we write here cycle for the A. But can we write form the cycle here for the B, because from this Q3 state A is transfer but B is not transfer anywhere. So can we draw here B? No, because at the substring only b is present, not n number of b's. Only single b is present in between two a's. So here if we draw the cycle for the b, then it is wrong. So what we do, if here anywhere b is came, then we transfer this b to this initial state. Here we transfer this b to here. Then again this ba kept their rule as it is. Substring is present here. So here only single b is present. And if the b's come, then we transfer back to the initial state. Now here in this state, now we reach to here. So for this q4 state, then again if we here form the cycle for the a and b, then it is okay, because after the aba substring anything can be we write. If n number of a if you write, then it is true. If you write n number of b's, then also it is true. So this is the PDA in simple. But now the TM machine is start from the null value, and the string we kept in the tabs. So how we put this string in the tabs? Like this. Wait, here let's suppose here is the tabs we construct. So first null is present here, and number of symbol is present, then null. Then let's suppose we consider only a string a, b, a, and after that also only one single null is present and n number of substring. So Turing machine first read null value. So for that we write here the transaction of the null. So we now draw exactly TM machine here. So Q0 state, this is the initial state which read first null value, kept this null as it is, move to the right. So we move to the right, we read a. So we kept this a as it is and move to the right. Let's consider this example. At the end what we want, this aba string is present or not. If present, then simply we move at the right side, and when here at the end of the string null is present, and if you read the null and all the this substring, then that's mean we are in acceptance state and we accept this string. So if you read a, then kept this a as it is and move to the right. If you read b, then kept b as it is, move to the right. Simply we move to the right all these symbols, because we want this rule aba maintain as it is, and remaining if any string is come, then we kept as it is. So a move to the right, b move to the right, kept b as it is, move to the right, a move to the right. Now here don't think anything, because when we construct the DFA, that time we think about this ABA, and initially we construct all the things which are we required to draw here. So here now only kept all the symbol as it is and A B right, then here also B and right. So this is the Turing machine for the substring ABA. So at the end we read null value. So if you read the null value, then kept this null as it is and move to the right, and we are in the final state Q5. So here we see we read if n number of A's, then we kept as it is, we add this, then we read B and then A, and we reach to the final state. But this is now the string which we write correctly here. If the wrong string is came, then also we cross check our Turing machine accept or not. That time our acceptation is the Turing machine is not accept the string. So let's we cross check this also, because now this all the correct substring is accepted by Turing machine. So wrong string is not accepted by Turing machine. Now it is happen or not, then let's we see here. So for that, let's suppose we consider the example ABB A. So this is the simple small wrong string, because we want the substring is ABA. So let's we start with this. So here null is present, after that also null is present. So we start from the initial state. We read null, we reach to the Q1. Then here we read A. So we go to the Q2 state. Then we read B. We go to the Q3 state. Again we read B. We go to the Q1 state. Then we read A. We are in Q2 state. Then we read null, but here null transaction is not present, means we draw the correct Turing machine. This Turing machine not accept the wrong string, only accept the correct right string. So in this way we draw the Turing machine for the substring ABA. So this Turing machine we represent in the another way also. So this is the wrong string. We let's suppose initially consider the string ABA. So at the initial state we are in the Q0 state. That time we consider the string is null ABA. Simply this substring we consider. So this is the initial state. Now we read in the initial state null value. So we kept this null value as it is, and we reach to the Q1 state. So Q1 state, and now we read A. After this null value we read A and BA null. Now after this A, when we read, we reach to the Q2 state. So right here in the next step Q2. Now write the string as it is, A null A, this B A null. Now we read this B. So when we read B in the Q2 state, we reach to the Q3 state. So right here Q3 null A BA null. After this B, we reach to A. We read A, we transfer our transaction to the Q4. So right here Q4, then null A B A null. After this A, we read this null value. When you read the null value, then we are in the final state Q5. So here Q5 null A B A null. So here we can say that we read all this string, and which we accepted by the Q5, means this string is the correct, and this is the Turing machine is the correct. So in this way we draw the Turing machine. Now if any doubt or any query, then let me know in the comment box. Thank you.